You know, if I were to want to, like, say, if I want to pull a fast one on my customers, I could go find a factory that makes a same cell size as mine and offers me a better price, and the performance might be lower, and then I just buy a bunch of those and make more profit. But I'm in this for the pure enjoyment of trying to make a difference, and it's my racing background. I started matching subsea cells on my kitchen table to have better packs for me and my friends. So to this day, my whole philosophy is to sell better packs for my customer base, because it's grown. It's not my friends anymore, but you know, it's to sell better packs, and that's what's motivating. Because to sell a 2S 5200 milliamp hour pack for a Traxxas vehicle, it's good. It pays the bills. It brings in income, but that pack doesn't need to have anything special. It's the other stuff that's challenging, like the EDF packs, the FPV packs, the speedrun packs. When you have guys going like 225 miles an hour with a 1/8 scale or 1/7 scale car, you know, it's that's fun.
Hi there, everyone, and welcome back to the channel. I'm really pleased today to be able to talk to Danny Sullivan. Danny is the founder and the chief battery designer from SMC Racing. And if you don't know SMC Racing, then you really should, because they make some of the best performing packs for RC cars and now FPV drones that I've ever tested. So today we're going to be talking with Danny and learning all about what makes great packs, a bit about his background, how he got into designing and making batteries for RC vehicles, and a little bit about where he's going to be going. I think it's going to be a fascinating discussion. We're all going to learn so much about what goes into making the best performing batteries for RC vehicles in the world. So with all that said, I'd like to welcome Danny. Hi, Danny. Thank you so much for joining us. And I guess to start with, let's start at the beginning. Can you give me a little bit of a background on yourself and how you first got into RC vehicles, RC racing, and eventually batteries?
Hi, thanks for having me. Basically, I turned my passion for remote control car racing, so 1/10 scale car racing, into a battery business when I was like 17 years old. I'm 56 now, so a long time ago. When I was 17 years old, I was buying subsea NiCad cells that we had to assemble 1.2 volt cells into 7.2 volt packs. So we'd solder our own packs, and you'd buy these packs in batches of 6, and they were supposed to be matched. So you'd pay more for the better ones and less for the. And after buying some very expensive packs, $120 back then for a 6-cell pack of 1200 milliamp hour. So just to let you understand, you and your viewers, how crazy this was back then, like how expensive, and how much batteries have gotten cheaper over the years. And then there was a company called Competition Electronics out of the United States, and they sold a charger that was able to charge and discharge the packs and give you the milliamp hour, the average voltage, and the resistance of the pack. And I bought this charger, paid like $350 for it. And when I got it, I was like shocked. It was like this small little charger in a plastic case. And I thought, wow, I just got ripped off. I ordered it on mail order. Yeah. But it was the best thing I bought, because it was able to grade my packs, and I could figure out which of my packs were helped me go faster on the track. And then it also gave me the ability to buy packs that were supposedly more expensive and better, and find out they weren't any better than some of my cheaper packs. So this led me to say, well, if I can't trust these companies that sell you these so-called better packs, I might as well figure out how to do my own packs. So I bought from Competition Electronics this machine they called a turbo matcher. So it was like a 6-cell device where you put 6 subsea cells, 6 channels, and it would do the same thing as a charger. It would charge them, discharge them, give you the milliamp hour, the average voltage, and the internal resistance of the cell. So I contacted Sanyo Canada, because I'm Canadian. I live in Canada, and I started buying like cases, 400 cells of subsea NiCads from Sanyo, and I started matching my own cells for me and my friends to have better packs. And then I started selling some to stores, and that's how it evolved to where we are today. So
wow, so it started off just with you selling to your mates, and then and then built a whole business from there. Wow, that's fantastic. I mean, SMC obviously it has a reputation, a big reputation in RC car racing, a big reputation in EDF jets, but you're pretty new to the FPV space. So for people who are FPV pilots who maybe aren't familiar with like the philosophy behind your battery designs, do you want to give us an idea of like what your philosophy is when you make packs with SMC?
Yeah, the idea is to make a pack that makes an impact and a difference. So basically, I look at the different applications. I talk with people that are in that market. For example, I've never flown an FPV drone. I've never flown an EDF jet. I'm strictly in the car side of stuff. But I know what makes a better battery. So I know how to test and know what, so once I understand what the actual application is looking for, I try to make a cell that will make an impact in that application. So basically, when it comes to FPV, many years ago, I did sell some really good packs. They were really reliable, had the best performance at the time, but I made a mistake. I tried to push the limits too much. And back then, I'm always learning. In life, you always learn from your mistakes, and you try to do less mistakes than good things. And I pushed the limits too much, and I came out with a series of FPV packs that had great performance, but like had no cycle life. Right. So I got out of it. Also back then, it was when people were racing 4S. It wasn't the 6S that people we see now. So I kind of got out of it, and I said, this is a bit complicated, and I kind of gave up on it. And because back then I didn't have the connections that I have now. Everything's gotten better. Back then it was more complicated to get cells done and stuff. So now, when like 3 or 4 years ago, I shifted to a different factory, different supply chain, which really helped me a lot. So I said, well, let's give this a go again. And because I kept seeing, people ask me, why don't you do like packs for FPV or something? I have people emailing me all the time. Why don't you do this, do that? I love your car packs. Why don't you do for this? I also fly this, or I do this. Hey, let's give this a go. And that's how I now do FPV. And also having success with EDF made me say, hey, I can have success in maybe FPV or other things. So that's how I approached it, and so far everything's been working out well, I guess. And I'm always trying. That's what motivates me.
Well, that's how we met as well, because you got in touch with me to test your packs to see how they performed against competition. And I don't know about making them any better, but certainly they are by far the best performing FPV packs for like 5-inch quads that I've ever tested.
Yeah,
which is why it's really exciting to be able to talk to you today. Did you have any sort of early challenges when you were starting up SMC? What's been the most difficult moment for you as someone who's created a business?
Okay, when it was subsea cells, it was very easy. Okay, so you'd buy cases of subsea cells and you'd match the cells. Of course, these things were made in batches, so some batches were better than others. So you've always had some fluctuations, but the market at first was controlled by Japanese companies. And it's a lot easier to deal with a Japanese company. They do business practices that are more similar to how we would do it in Europe or Canada or USA. Then all of a sudden, it shifted to the Chinese, started making these subsea cells. So it became more of a challenge. For example, at the end of the subsea era, a company called IB, which now does lipos for cars, which is called IP, made the best racing cells, the best nickel metal hydride racing cells. But to make sure they had the best cells, they compromised safety, reliability, and safety.
Oh, wow.
So the cells were blowing up. Well, that's the challenge of dealing with Chinese companies. They are focused on sales and money and turnover, and sometimes they cut corners. So that's I think it's the biggest challenge, to try to have to deal with them and make sure they do a product that will not have major issues. There's different levels of factories. There's like you could call it A, B, C, or tier 1, 2, 3. And so the C, or tier 3, like the cheaper ones, these cheaper are small factories with like a poor equipment, no proper QC, but they're cheaper. So
yeah. Well, I think that sort of brings us really nicely into the kind of first kind of section that I wanted to talk to you about, which is going into a bit of a technical deep dive on what makes great batteries, what goes into the design and testing of a really great battery. And I think this is where the people who are racers or maybe people who are more enthusiastic in the hobby will really perk up, because I think that you can explain what makes a great battery better than anyone I've spoken to before. What are the top 3 characteristics that you are always aiming for when you're designing these types of racing batteries?
You got to have it for each application. So for example, I can sell a series right now, which I call my SRD series, which is a speed run drag packs. Well, these guys are looking for maximum voltage under short high amp bursts. So like maybe 500, 600 amp bursts for like a few seconds. Or 1 point, like in drag racing, they're like 1.2 seconds. And so it's just a massive, so a cell like that has its different challenges than, let's say, somebody who flies an EDF jet. Somebody who flies an EDF jet, he wants high voltage, like wants to have the voltage stay good, like be responsive, not sag a lot under a load. And they're around 150 amps, something like that. And they want to fly as long as possible. So that's another challenge. So then you got to work on having the cell retain the voltage under load. So that's related to the C rate, assuming there would be such a thing as real C rates, which there kind of is, but there's no real standard. Okay, so
we'll talk about that later for sure.
So you do C rate, you know, versus your milliamp. I always refer to milliamp per gram when it comes to cells. So if you can increase your milliamp hour per gram and keep your C rate up, then you're giving more flight time in this application, and you're keeping the voltage under load better. The FPV cell is similar to the EDF cell, where they want as little voltage drop as possible, so they can go as fast as possible from point A to point B, or their laps that they're doing, and they need to be able to have enough capacity to be able to finish the race. So that's kind of like, it's similar to EDF. And then of course they want the weight to be as light as possible, because the drone, I guess, handles better when it's lighter. So once you understand what they're looking for, then you try to challenge. Like in my case, I challenge the factory, the engineers, and I tell them what we're looking for, and then we try. It's trial and error. And then what makes a better cell than another is basically, think about it as a cooking recipe. Why does one spaghetti sauce taste better than the other? It's the amount of ingredients, different ingredients. Somebody might put, like, I don't know, something special, other ingredient in the spaghetti sauce that makes it taste better. Well, a better cell is finding the ingredients that gives you what you're looking for. And when it comes to battery materials, there's thousands, if not hundreds of thousands of different combinations and materials. Like you're talking about the lithium cobalt oxide. There's different qualities and places that makes better ones. And then like you have your graphite. You can have like better artificial graphite or real graphite. Then you have your conductive agents such as carbon black and carbon nanotubes or graphene or other, you know, it's a mix of everything. So if you find the best of everything, you're making a better cell, and or as good as you can. And even the cells I get done for me, I'm sure they don't have all the best, like they have very high quality materials, but I'm sure we haven't figured out the best recipe yet. And someday we may stumble on a different material that may give that little extra 2-3% or whatever. And that's what I'm always trying to achieve, which is not always easy, but you know, that's always the goal.
So for people who maybe aren't familiar with kind of the nitty gritty of the like construction of a battery, can you talk us through like what are the key elements that go into a lithium-ion battery, and then what you're looking at when you're trying to optimize each of those elements for a particular application? Let's talk about the FPV packs as an example. But you know, as you go through each of the components, can you sort of talk us through it, and how you would go about fine tuning each one?
Yeah, so basically it's pretty much every cell I sell, like that we offer, uses the same basics. So basically there's the cathode, which we use lithium cobalt oxide.
Yeah.
This is the best material for high energy, for like low voltage sag. So for remote control car applications such as racing or whatever, lithium cobalt oxide is the way to go. If we were to use nickel manganese cobalt or lithium iron phosphate, we'd have like big voltage drop or no, like a very big drop in power.
And that's
so lithium,
the most expensive cathode,
yes,
right?
yes, it's more expensive. And then for the anode, then we have the anode side. It's artificial graphite is used in the RC type of cells. I'm not going to lie, I'm not 100% sure why they don't use real graphite, but there's a reason behind it, and I've never really asked the actual question. I think it might be for cycle life. I think real graphite might degrade faster.
Yeah.
So
and those materials, they're plated onto foils, aren't they? So you've got a
yeah, they're coated on foils. So the cathode is if I have it correctly, the cathode is coated on aluminum, and the anode is coated on copper. Right. And basically that's it. And so we're using the same basic materials, but then it's like how you work with the C rates. So basically amp hour and C rate. So let's say C rate exists, which it does, but it's very messy. But let's say it exists. Okay. So C rate and milliamp hour is kind of like torque and RPM. They work against each other.
Right.
So you can't increase C rate and increase the milliamp hour. One comes at the expense of the other. So that's where it gets tricky. But then you can manipulate the anode. You can add a bit of advanced silicon material in the anode, so you boost your milliamp hour a bit. Yeah. And then we can play with the separator thickness, which is what separates the anode and the cathode from shorting out, and it lets the electrolyte and the ions flow through. So basically, separator thickness is one way to increase your milliamp hour per gram, your pack's capacity. But there's nothing free in life, so there's a downside, right, which could be a bit of a safety, or cells could tend to have micro shorting. I'm sure a lot of your viewers have had packs that have the odd cell that dies or loses. Every cell is going to be at 383 storage voltage and one's at 356 or whatever. Well, that's a cell that's micro shorting, so it's losing some of its capacity. And sometimes they just flat out go to zero volts.
I've had that happen where just one cell in a pack will just suddenly die for seemingly no reason. Yeah, but that's a cell that's micro shorting. That could be due to contamination inside the cell. It could be a forming of dendrite that shorts the cell. There's a lot of different ways that this could happen, and it happens. I've dealt with 8 different factories. There's yet to be one factory that can deliver 100% defect-free cells. There's always going to be the odd cell that's going to have this. And if you don't take care of your cells, it could be more prone to happen also. It could be caused also by the user to a certain extent. And so you've got those sort of different materials that you talked about. And then I guess, as you say, you're playing with the different thicknesses of the foils, different thicknesses of the anode and cathode material, and then different separator thicknesses. And obviously the balance of all of that is what gives you the best.
It gives you the performance. For example, if I want to my car, like the car racing packs, what we're looking for is to keep the voltage as high as possible at lower amp rates, because we really don't pull high amp rates in car racing. In car racing, it's we pull anywhere from 10 to 30 amps, maybe short peaks of 50, 60 under acceleration. So we're trying to hold the voltage as long as possible up front. And the way to do that is to increase the milliamp hour per cc of the cell, because in car racing, we're stuck with the packs have to be in this plastic case. We call it a hard case. It's just a plastic case, and they're regulated for racing, so we can't go bigger. Right. So we have to increase the milliamp hour per cubic centimeter of the cell to try to increase the voltage curve. And
Yeah.
the other thing that increases the voltage curve is lowering the DCIR. But to lower the DCIR, this is achieved by conductive materials and C rate again. So one works against the other. So it's a very tricky situation. So the typical car racing packs, a lot of the times, like the way I test for C rate, 15, 20 C is enough if we have enough conductive materials in it. This season, I came out with a 40 C cell that has very similar capacity to 20 C. So by testing on the equipment that I have to test, I look at the curves of the 20 C cells versus the 40 C, and I see which one holds voltage better in the first part of the discharge curve. And I found that this year, like this newer formulation with 40 C, because the DCIR is lower, is actually better. So this year's like what I call my the RS car racing packs. I have like 3 different or 4 different models right now. They're a true 40 C. Of course, we labeled it as 150 C to keep up with marketing demands, and that's a whole problem with the RC battery industry. But
C rating is just ridiculous.
Yeah, it's there is no such thing as like if somebody can find, if one of your viewers or anybody can find like an actual definition or certification of how to test for C rates, I'd love them to send it to me or you, and because I've never found them.
I had to make up my own C rate test.
Exactly. So I do my own way. I have my criteria, and that's what I do. And the factories have a bit of their own criteria. For example, one factory may say, "Oh yeah, the cell has to retain 80% of its capacity if we discharge it at the claimed C rate." Then you talk to another factory and they say, "Yeah, the cell has to retain 90%." Well, that's a big difference.
Yeah.
So it's like
a huge difference. And how do you get your designs manufactured? So obviously you're testing all of these cells, you're adjusting all of those dimensions and parameters and materials, and then do you manufacture the cells yourself, or how do you get them made?
Okay, basically, I have no ability to make a cell. The equipment to do it would be very expensive and not feasible. And then second of all, I'm more of a cell testing engineer and not like a battery engineer. So I'm not a chemist. I can't make a cell. So I don't have the knowledge. I could probably learn, but so how it works is you just got to rely on the factory you deal with, and you communicate with the engineer, and you give him ideas, and then he comes up and makes sample cells, and it either works or doesn't. Sometimes it works and has very poor cycle life. Sometimes it has very good cycle life, but it's not the performance I'm looking for. So there's one of my car models. I asked them to try a cell recently, and I wanted to use a different formulation and tried something else. And it came in, and it's just a bit better than the pack I'm selling now. So I'm not going to release. I could release it. It's a bit better, but I'm not the type of company or person to just release something that's just a bit better. You
want to wait until there's a real
there's a bit of difference, because it's good that people, all the racers would go crazy and start buying like a lot of these new packs, but I don't feel it's fair to like take advantage of them, to just give them something a bit better. It's like I guess so I've got another cell that they're working on now. I'm trying to always make it better, and so I release, and that's another problem in this industry. A lot of customers are getting taken advantage of by relabeling of the same cells as a better cell, and that's that's super unethical. And I will not name names because that's not my style, but there's one of the major players out there that has done that with some of their racing packs. And I'm there, wow, why are they doing this? Do they need the money so much? Like, what's going on? And it's like I have the graphs. I could share you the graphs. They're like, it's exactly the same cells. In fact, like when you do batches of cells, there's some that are a bit better, some that are a bit worse. Like they can fluctuate a bit. And guess what? Their newer labeled pack that they said is 140 C instead of 130 C actually has a bit lower voltage curve than the one that was 130 C.
just from the batch to batch,
So imagine the person that paid like $90 for a pack, and he loves this pack, and it runs great, and it's a great pack, and he likes it, and said, "Oh wow, I'm racing, I'm competitive. they just released a better pack, 140C, a new pack, a version whatever.
Yeah.
You go buy, you take another $90 of your hard-earned money
And buy the same
put it in your
battery
car
again.
and say, wow, it's not doing anything different. It's like
Yeah.
but it's sad to see what some companies will do, but it is what it is, I guess.
It is what it is. I certainly sort of, I kind of understand where you're coming from with the kind of working with a factory thing, because obviously I do motor design myself.
Yep.
And I'm kind of in the same position. Like, I can't make neodymium magnets. I can't draw copper wire. So I have to work with a motor manufacturer. And the nice thing about having that kind of testing focus is that pretty quickly you realize who makes the best in the market right now. And then those are the people that you work with, because you're like, they know what they're doing. Now let's work with them to make something even better.
Yeah, even like factories, like they all have engineers, but if like your factory, like the factory's design capabilities and performance is directly related to its engineers. If the engineer doesn't know, because it's a recipe, so it's a recipe. So unless you know exactly what these other factories are putting in their cells, you can't copy another company's cells. It might be possible, I guess, if you get cells and send them out to like a really high-end lab and have everything like torn down and the materials analyzed, but it's not something your typical Chinese factory will do. I'm pretty sure like the bigger factories like BYD, CATL, they're like
probably
studying each other all the time, so they probably can do this and put the money, because I'm sure a lab that would like dissect a cell and give you the like every makeup of every material, the size of the particles and stuff, I'm sure that's very expensive. So your typical RC factory will probably not do that. So
much cheaper to just poach the engineers from the other factory, I think.
That's what they tend to do. So when your engineer leaves, he leaves with his own, he leaves with his spec sheets, and then that's it. So that's how it works. It's that's another thing. Another thing that makes, on the subject of what makes a better cell, is the equipment it's made on makes a difference. So if you're running like the quality of your machines, like your machines, like the electrodes, once they're coated and dried, after that they're pressed. Well, something as stupid as like your roller that presses the electrodes, if you have the biggest roller that can put as much more pressure than another one, it'll help the performance of the cell. So so the factory I deal with right now opened a new factory a little bit over a year ago. So it's all the latest and greatest equipment. So that helps a lot too. So if you're dealing with a factory that's got an older factory with older equipment, we're talking small differences, but when you're trying to make the best cell, you try to use everything on your side.
Yeah, even a few percent here and there, it's,
exactly.
You take everything you can get.
Yeah, exactly.
So you mentioned a bit about DCIR when you're talking about how you test packs.
Yes.
So how important? So I know that a lot of people measure the DCIR of their packs, like on the charger or when it comes off the charger. How important is that number for the real world performance of the pack, and what's really going on when we measure it, and how does that change when you're actually flying the pack or using the pack in a RC race car?
Okay, basically DCIR is kind of very important. The only problem, very few chargers measure it properly. Very few, on my SMC Racing YouTube channel, there's very few things on there, but I did a video showing how chargers are so inconsistent in measuring DCIR. So when it comes to a charger, it's a reference point. So if you use the meter, like the ESR meter that we offer on our site and is available at other places, I think even Hobby King was selling it for a while. That's a more precise way of measuring IR. It gives you how well matched the cells are, and typically I use it at storage level and at 22 degrees Celsius or 72 degrees Fahrenheit, because it doesn't take much. You just take a cell, squeeze it in your hands for 40 seconds, the IR just went down.
Wow. So they're that sensitive to temperature.
It's very, or put it in the fridge for for a minute, it goes up. So it's very, very sensitive. So you've got to measure it at the same temperature all the time.
And the same voltage as well, right?
Yeah, storage voltage. Fully charged, it'll be a bit lower.
Okay.
No charge in the cell, it'll be like crazy high. It won't be able to test properly. And I think it has more to do also with how these meters work to a certain extent. But so basically, it's a very important factor, because if you have two packs, let's say the same weight and the same, let's say, C rate in question, like if they can both do about the same C rate, the one with the lower DCIR, if you load up that cell, let's say at the, you both load them up at the same amps, the one with the lower DCIR is going to hold a better voltage under load. So that's
right. So it's all about the voltage sag.
Yeah, where it gets tricky, some people swear by this all the time. So they say, oh yeah, this pack. It could be misleading, because there's other things inside a cell that can impact how it holds voltage under load. So by this, I mean my FPV packs, my FPV cells, okay? Part of it is because they're so light, okay, is my 1400 FPV cell has a bit higher DCIR than some of these other companies' 1380s.
Right.
And you say, well, why is that? Well, there's two reasons. One reason, it could be how the materials, could be partly materials, but the other reason is my cell is lighter. So if you want to compare, it's kind of like my 1600 has better IR than my 1400, because the cell's thicker, it's bigger, so there's more layers of electrodes. It lowers the DCIR. Well, my 1600 sometimes is close to some other companies like 1400s or something like that. So my IR of my 1600 is similar to some of these other companies' 1400s.
And this is what I noticed on the testing, is that the weights of those packs aren't the same as like the equivalent milliamp hours from another manufacturer.
Yeah,
so a lot lighter.
Yeah, so on the IR, it could be a bit misleading. So part of it is that, and then it's also the formulation. Maybe a bit different, and there's something in the cell, there's a bit of an additive or something that, even if it doesn't really lower the DCIR, helps the voltage hold under load. So it could be I've seen cells that are like 20C that have the same DCIR as 40C cells. So you'd say, oh my God, this 20C cell. So if you wouldn't know the C rates, you'd say, oh, the 20C cell is every bit as good as this 40C. So if you load if you do a 10C test on the 20C cell and a 10C test on the 40C cell, the curve of the 20C may be a bit better because it's got the same or lower DCIR than the 40C cell.
Right.
But if you load up the 20C cell at 20C, it's going to have tremendous amount of voltage drop, where the 40C cell, it's only half of its C rate, and it'll have much better voltage under load. So it could be a bit misleading. So that's why you can't use DCIR to measure C rates. Some people, like the ESR meter that Wayne Gills designed, when they did all the R&D and testing, it could give you an approximate safe C rate. But even they admit it now today that there's materials, something's changed, that doesn't work anymore.
Yeah, because the DCR, obviously you've got the leads of the battery, the tabs on the cell, the foils themselves. Those are all sort of the just resistance. And then you've also got like the chemistry of actually that ion transfer inside the pack. And that's going to be affected.
Yeah, and when the meter, the way the meter measures it, though, it measures it really at the tab of the cells. So it measures it through the balance connector. So basically it's using the voltage sensing leads, like the balance wires, as voltage sensing leads. So it's like a Kelvin connection. So it's a 4-wire setup. So that's how it measures it. But the meter also gives you the IR at the connector. So that's good. Sometimes you can say, hey, why is this pack a bit better than the other, but the cells aren't better? Then it tells you your connector has corrosion or is not good. So it's another good way to check, because connectors, there's no connector that you take, the more you connect it and unconnect it, it's not getting better. There's just like when you charge a battery and discharge it, it's not going to get better. It's only going to get worse from where it starts. It's like there's some people that are there, oh yeah, it's like It'll always be a drop.
Some people do talk about like conditioning batteries by charging and discharging them.
Yeah.
I mean, that's done in the factory, isn't it? And
yes,
you're not gonna improve on it.
I'm not 100% sure of this because it's like the first lithium cells that were sold for RC were for flight. They were 5 or 10C back in the days. And in the car stuff, we didn't use those. Like the IR was simply too high. A LiPo, you charge to like like we were using like a 1.2 volt cells times 6. So that's like 7.2 volts. A LiPo is rated at 7.4 volts, but you can't charge a LiPo as high. A nickel metal hydride cell would charge higher. So we'd had more voltage available
at the start.
Yeah, but the IR of a nickel metal hydride cell is much higher. So when like for example, the first 5,000 milliamp hour cell I tested, like a LiPo cell, on the meter, like on an ESR meter, the cells were around 12, 13 milliohms. Right. I sell a pack right now that's like a 6,500 milliamp hour, I believe, and the IR is 1.5, 1.3, 1.4. So that's how much better it got over the years. It looked like it gotten a lot better. So when the IRs went down, we said, okay, we could start using LiPos. But I think when the first LiPos came out, I think there was some additive, there was something in the cells that if you did a break-in, they'd get better. So I think they're not using that now. Or maybe back then the factories weren't cycling the cells as much. I'm not sure. That I don't know. I'd have to, I'm not even sure how I'd find that out. But there was something different back then. But basically now I can take like, I receive sample cells. I can take a cell, put it on my high C rate tester, like to test for like 300 amps, or if it can do it, and I can discharge it. And if I take one that I cycled a few times and discharge it, it doesn't do anything better. So I tell people there's no need for break-in, but maybe if the pack's been sitting for a long time, it's not a bad idea to charge it up and bring it back down to storage charge. Just make sure the materials are a bit active. Maybe that could be good, And then there's also cold weather.
That was the next thing I wanted to talk to you about. Was you were saying DCIR is very, very dependent on temperature.
Yeah.
So how do RC car racers and how should FPV pilots manage batteries with regard to temperature?
Well, when it's very cold, you got to be careful, because basically if you're using like people that fly planes, a lot of them still use cutoffs. They're kind of like these soft cutoffs, and the motor will cut power or something, so they're not going to lose all power. But you got to be careful, because if the pack is really cold, it's going to have a lot of voltage. It's going to hit the cutoff a lot earlier, so it's going to have a lot of voltage drop. It still has capacity in it, so it's almost you need to, that's what I always tell people. Cutoffs are not that intelligent. You kind of got to adjust them, and so if it's cold, you can run a lower cutoff, but if it's hot, you need to run a higher cutoff. So you've got to really be careful, and that's the other thing. Discharging cells under load too low kills them. And that's a lot of people do this, and it's one of the there's not a week that goes by that somebody says, hey, I've got one of your new packs, it won't charge anymore. I said, did it happen after you ran it? And he said, yeah. Well, I said, get me the voltage of the cells. There's a good chance you discharge them down too low. Then the guy emails me, and the cells are at 2.3, 2.8 volts. And then the chargers, when they see that, oh, there's something wrong, I won't charge. There's a safety thing. So that happens a lot, and people don't know, and they just run batteries down way too low, and they damage them.
For the temperature thing, then I know racers who chuck all their packs in a bag with some of those hand warmers.
Yeah, to warm them up. Yeah, that will lower the DCIR, so it'll help the voltage under load stay better.
And how hot is it? How hot is it safe to get them in sort of
general rule of thumb? You don't want to get your packs like above 60 degrees Celsius,
right?
But that's a rule of thumb. But they can handle it. They can handle being a bit hotter. You risk forming a bit of expansion, a bit of gas buildup. But and that's another thing when it comes to lipo swelling. There's a big difference between a cell that has a bit of expansion, gets just a bit deformed because a bit of a gas buildup, or one that becomes like an airbag.
Yeah, it really puffs. Yeah.
Yeah, exactly. And a lot of people get like I'd say, angry or think the cell's not good if it gets like lithium cells per nature. First of all, cells expand and contract. So like on your end, you're able to test this. If you take you could take a pack or a cell, in the discharge state, it's actually thinner than when it's charged. So there's a bit of expansion going on there. If you get a cell really hot, it'll expand, stay kind of like flat, but it'll expand. It'll groan a bit, and then if you get them way too hot, there's gas buildup. Sometimes there's gas buildup and it goes away. It goes back down when it cools down. Sometimes it stays.
Okay, but like 40 degrees in a bag with a hand warmer is a good, that's going to make sure that your pack, if it's a cold day especially, it's going to make sure that your pack.
You got to be careful, but you got to remember, if you're going to be pulling a crazy amount of amps for a long time, if you start it hot, it's only going to get hotter. So that's where you got to manage it. There's these little like I started putting it on my high voltage EDF packs or flight packs because this series, I'm very proud of this series, but at the same point I was about to maybe not offer it anymore because you'll take a customer, might have like 6 or 8 of these packs,
right?
Loves them, says they're the best thing he's ever flown. He gets higher flight time, he gets more power, loves them. Gets good side, like has no problem with cycle life. Like any other lipo, there's the odd one that can go bad. We warranty for 1 year if there's an issue. Like I'm fine with like doing warranties with the manufacturing defect. Then you have another customer who does flight. It's not the same planes, whatever. It's not in this. Every pack he has, they go bad. The IRs go way up.
Right.
Like the packs swell. The guy's really not happy with it, and I was there. Man, this is weird because I do my due diligence when I test cells.
Like you test
for cycle life and everything, but I can't duplicate real world use. I can't build packs and go fly them. I mean, that's not what I can do. So, and I always send samples to get people to fly them, and they said they're good. I'm there, man. So this taught me a lesson of saying, wow, there's something going on, and some people, you try to get information. One of the things that I notice a lot of people do in RC flight is they love to keep their packs fully charged for the next time they want to go fly. Well, that kills the packs.
Oh yeah,
but they don't know, and they've been doing this. And guess what? There's some brands, like not, it doesn't have anything to do with brands, but there's some cells designed out there that are less susceptible to having issues if you keep them fully charged. But in the high performance sphere, if you don't want them to degrade, they can't handle it. And the electrolyte in HV cells is not the same as non-HV cells, and it really doesn't like to stay fully charged. So this
is something that I've really noticed as well, is that the biggest thing for like packs puffing up or degrading relatively quickly, like is just how long they've been fully charged in their lifetime. Like the best thing you can do is to charge your pack like just before you go out and fly, and then discharge it and then charge it back up to storage.
Or like 1 day is not going to kill anything. It's probably not going to help, but it's not going to be it's not the end of the world.
But it's cumulative, right? Like if it's a day here and a day there and a day and a day and it's
the same, discharging too low under load. Like in fact, you have all your equipment with your cutoff, and like you can take 2 packs of the same brand, same batch, and do both packs at 60 C. Do one to like 3 volts per cell, so down to 3 volts per cell. Do the other one at 3.4 volts per cell, and do 20 cycles, and take your base readings, and the one that you stop the discharge at 3.4 volts. I'll bet you any amount of money is going to have much better. It's going to retain its capacity, its IR. Everything's going to look much better after 20 cycles than if you keep discharging it. So because a lipo cell, the last bit of the discharge generates extra heat. So when it's getting depleted, it just generates more heat. Any cell I discharge down lower, the rise in temperature in that little bit is much higher than it just increases the overall temp. So
because you're depleting the chemistry, aren't you? Just at the last bit.
So that's why I tell people, man, set your cutoff high enough. Ideally, you should fly your packs and come back when you land, or bring back your boat or your car.
Yeah.
You should look at your cell voltages, and you want them to be in the high 3.6, low 3.7. If you follow that rule of thumb, you're not, you don't risk damaging them from discharging them too low. But
Yeah,
unfortunately, a lot of people don't know this, or when it comes to the car market or the boat market, these ready-to-run cars and trucks, they have these ESCs, and the ESCs, they don't care, the companies that sell you a car or a boat or whatever, they don't care if you crap out your batteries. That's not what they're selling you. So they have the cutoff set too low.
Well, I mean, I noticed that. I mean, when I fly my packs, I fly them down to 3.5 volts per cell under load.
Yeah,
and then,
exactly.
of course, when you land and disarm, the voltage jumps back up to like 3.6, 3.7
Yeah,
immediately.
well, here's the kicker though. If you can take the same pack, pull, let's say 100 amps out of it. Let's say it's a pack that could sustain like 100 amps. You pull 100 amps out of it. Well, the cutoff, it may handle 3.4 cutoff. But if you take that same pack and you pull 50 amps out of it, you've got to increase your cutoff because it's not making the voltage drop as much. So you kind of got to adjust your cutoff. That's why I tell people, like if you play on concrete, in theory, the cutoff needs to be higher than if you play in mud. In mud has a lot of traction, so it's making the voltage sag more. So these cutoffs are not really. It's like they're very tricky.
Yeah, you need to sort of, as you say, you need a bit of experience with it. We've talked a lot about like what goes into the battery. Once you've made a pack, can you tell us a little bit about how you do like the QC on the packs that you design, a little bit about cell matching maybe, and how you ensure that, when you're getting batches from your factory, you get consistent performance, particularly because, all of the packs I think that you sell are targeted at that sort of high performance market.
Yeah, well, I have a bit of control, but I don't have 100% control because I'm not the one doing the entire process. So basically, every cell factory has their matching process. It's not perfect, and the reason why, there's a lot of reasons at play. Okay, the cells are cycled on these cabinets that have multiple cell holders. So it could be like 64, 128 cell channels.
Wow.
Okay, so they charge and discharge on those, and then they grade the cells after it's been formed and cycled and aged, so they can grade the cell. Well, it's pretty much impossible to have every channel be perfectly calibrated. I'm sure they're well calibrated, because when I used to do subsea cell matching, I had like 35 units at 8 channels, I believe. So that's a lot of channels to keep. And I noticed when I grade my cells, I noticed, wow, I'd have every machine had its number and its cell holder. So when we print the label of each cell, I know it come from what machine. And then when you put cells on a table to grade them, build them in the pack, I noticed, wow, a lot of my highest cells come from this one cell holder. So then what I'd do is I'd retire that cell holder. But I don't believe the Chinese factories pay attention to that as much, And then the same for measuring IR. They use ACIR, they measure it. And it doesn't always correlate perfectly to DCIR, but overall, I'd say the matching is pretty good on the IR. It's not as tight as I would like it to be. And I've tested cells and packs, and like packs from various companies that, for example, a good factory is Gripau, which does like the Gen Z's tattoo stuff. They're a big factory. They've been doing and they've got a barcode system for their grading and matching. And I recently tested one of their 2S racing hard case packs, and there was a decent discrepancy between both cells for IR. So it's just part of the deal. For the most part, it's well done and all right, but it's not a perfect thing. And the same for and the same for the capacity. It's like within reason. They're really well done, but it could be a bit off. And then you got to remember, you can have everything super well matched, and guess what? A lot of the chargers people are buying, I would call our entry grade level chargers. Even if they're nice and they've got nice flashy displays and claim to be whatever, but most chargers are made to be sold at the lowest price possible, and they're not spending a lot of time in calibration. So if the calibration is a bit off, then you're charging a cell a bit more than the other. So then when they discharge, they don't discharge. At the end, there's a bigger spread. So I did I think, or it might be on my website, and I showed like using a different charger, I can get different results.
Yeah.
Because so the matching is done by them. Batches are made of course, in batches and production runs, and then you're limited, or you're at the expense of how well they duplicate the recipe. So they have to measure everything properly, and you're also if there's fluctuations in your recipe a bit, there can be fluctuation in your raw materials. Is the LCO company, like every batch of LCO, 100% the same? Maybe, but
there's always a tolerance on it, isn't there?
Yeah, exactly. So then you get a batch that's a bit better. I've tested like the FPV cells. I've tested like I think we've had like 2 different production batches and 2 different sample batches. And if I were to send you the graphs of each, they're all a bit different, but they're within reason. And a cell within a batch, there's a bell curve. So there's a bit lower cells, a bit higher. There's a sweet spot. There's a bit higher, a bit lower. And when you have to use up the whole thing, the whole batch. The same for when if you were to discharge every single cell under like a high amp load, they all have a bit different reaction. And that could be a bit correlated with DCIR, but it's not 100% correlated with DCIR. There's other things at play in that too. So the matching is kind of, it's pretty well made. A good factory will kind of duplicate the batches pretty consistently. If they don't, this is where it gets tricky, and it's the Chinese angle. Is sometimes they'll try to cut costs on you and try to change something. And I have protections in place to prevent that. But I want to say the factory I deal with now is pretty good at it. I've not had this issue with them. I just see normal fluctuations.
Yeah, that's really important as well, to have someone that you trust to do the right thing, in terms of consistency. And
well, that's where you learn. That's where over the years of dealing with a foreign country, different mindset of people, how they think and what, and
different company cultures as well.
Yeah, and you try to like learn and adapt, and you try to put something in place to protect you, and that's what I've done. And so far it works. And if there's ever an issue or a mistake, I'll work with it. And like I said, let's say my FPV racing packs hold a bit less voltage under load, and I notice it's a noticeable difference, I'll just flat out say, hey, the power under load is a bit down. Here's a discount, and people would probably still buy them at a lower price. It'd still be pretty good. I don't think they could mess it up that they'd become really bad.
Yeah, I mean, I don't know of really any other battery company that I would think would do something like that. So that's the nature of it. Like,
well, I've seen it. There's one of the big China company pack resellers that sells in every country. They're everywhere, and they do promotions and stuff. And I remember Joshua Bardwell had tested one of their packs and said, "Oh, this is an amazing pack," and I got one. And I'm there, wow, this is really not that good. Then I got another one a while after, and that one was good. And I have to assume either they're using a factory that has really poor ways of producing batches, or they shop like a lot of what I call pack. Like, that's one thing with China. Everybody claims to be a factory when they're not.
Yeah, some people are just either reselling or
I call them pack resellers. And in fact, I used to buy from pack resellers. I've only started dealing at the factory direct for the last 4 years, so that's why I have way more control on my destiny right now. But the pack resellers will get a deal from a different factory, and they don't care. They don't care. They don't care. Like, they just sell packs. They sell packs, and whatever. It's 120C, 1500. It's in the orange shrink or blue shrink or whatever, and they keep it in that. It's a different cell, because these cell factories all make cells at similar sizes. They all duplicate their cell, like the cell
Yeah.
formats are very similar from, like they all have my cell format is the same cell format as a tattoo pack. And there's a reason for that, because that's the pack I was always told, oh, the tattoo R line is the best cells, best packs. So that's what I bought those, and I tested those, and then I said, well, okay, people are used to that. Let's make our pack the same cell format so people can put it in where a tattoo fits.
Yeah.
Well, you'll have companies like Dogcom and Bonka and others. They have a bit different cell size. It still fits in the same place, but they're using a different factory that has cell tooling that's a bit different cell sizes. But they're all similar. So it allows like if I were to want to, like, say, if I want to pull a fast one on my customers, I could go find a factory that makes a same cell size as mine and offers me a better price, and the performance might be lower, and then I just buy a bunch of those and make more profit. But I'm in this for the pure enjoyment of trying to make a difference. And it's my racing background. I started matching subsea cells on my kitchen table to have better packs for me and my friends. So to this day, my whole philosophy is to sell better packs for my customer base, because it's grown. It's not my friends anymore, but it's to sell better packs, and that's what's motivating. Because to sell a 2S 5200 milliamp hour pack for a Traxxas vehicle, it's good. It pays the bills. It brings in income, but that pack doesn't need to have anything special. So that's easy.
No.
It's the other stuff that's challenging, like the EDF packs, the FPV packs, the speedrun packs. When you have guys going like 225 miles an hour with a 1/8 scale or 1/7 scale car, it's that's fun. In fact, there's a cool project I did. There's a drag bike, a real drag bike, that does they do electric drag bike, and I've been helping them and sponsoring them for the last couple of years, and they've got the speed record at the Texas Mile in Texas. It's like they do this run which is a Texas Mile, and they did the record last year with my packs, and before that they had the speed record at the Bonneville Salt Plains. So it's fun. Stuff like that. It's fun. It's fun to do outside RC stuff. So I'm kind of known for high power, like lithium cobalt cells, I guess. And
well, I know that you were working with Luke on his world record attempt. I've been working.
Yeah. I've got a new batch of cells ready for him. I've already sent him some, and he wanted more. So that's fun. It's fun to see what the cells can do. Can I make a difference? Yes or no? I don't know. It's just fun. It's just some fun stuff to do. And it's the same with the speedrun guys. That's a whole other crazy market, and it's just fun to do cells for different applications. You'll never sell thousands of packs, but it's fun to be the go-to guy for stuff like that.
The interesting projects, right?
Yeah, exactly. So it has to be fun.
Yeah, it has to be fun. So I think we've got to come on to testing now, and we've got to talk about C-rate.
Yes.
Because I think there's just everybody, I think, in the FPV community now kind of is aware that the C-rate the manufacturers write on packs is sort of a fiction. But
that's why there's no C-rates on my packs. Because where does it stop?
I think have the best understanding of this of anyone that I've spoken to. So do you want to give us a little talk through of what C-rate is and how you test it? What people should be looking out for?
Okay, so basically C-rate is a real thing. Okay, and if you were to test cells from tier 1 factories, factories that like BYD, CATL, they make like semi-solid state cells. Okay, so for example, like something like this, like a big semi-solid state cell. Mm-hmm. If they say 5C, it'll do 5C. They're not, it'll do 5C on my way of testing. And I've had an understanding of C rates for many, many years. And in fact, once again, on my little YouTube channel, there's a video in there in 2012 I did where I had my own setup that I custom made to test for C rates. And I learned how I was getting lied to by pack resellers.
Right.
Okay.
For your test, when you say when the pack says 5C, That means that if you discharge it at 5C from fully charged to fully empty, you
To
get
okay. So the cell has to give at least over 90% of its capacity. The
Right.
cell needs to give 90% of its capacity. But another thing I look at, you can't have the voltage sag and recovery. So the dip and recovery. Dip and recovery to me shows that you're getting the cell excessively hot. So the IR is decreasing rapidly. So it makes the voltage go back up. But to me, that's like stressing the cell too much. So if you were to do like a cell like that, you'd do probably, I don't know, like 5-6 cycles at that C rate, it'd probably crap out, probably wouldn't be able to do it. Where if it doesn't have the voltage drop and recovery, it could do more cycles at that C rate. And another thing we got to understand with C rates, the cells are stronger than the way we're assembling the packs.
Right.
You know, so like my speed run packs, the previous ones were like, I'd say like 60, 65, 65C, 60, 65C, and I was selling, let's say, a 10,600 milliamp hour pack. So technically, you can discharge 600 amps out of that. There's no way you're going to discharge 600 amps out of like 8 gauge or even 6 gauge wire could do it for a while. The connector, it wouldn't work, you know. So
you just melt the connectors, right?
And plus RC, it's still, we're dealing with bursts, you know, you know, because if a cell, any cell you discharge at full C rate will last like 50 something seconds. If it can really do its C rate, it's around 50 something seconds from full charge to discharge. That's regardless of the cells.
Yeah, well, if it's giving 90% of its capacity, you know it's got to go for 54 seconds, right?
Yeah, exactly. So basically, what I look at is the voltage drop under load, and then there's some stronger C rate. Like you can have a cell that can do 40C, and another cell can do 40C, and one formulation is better than the other because the other one will sag to around 3.4 volts and stay there, and then go back down. Where the other one will stay, like a strong cell will do 50% of its discharge and stay above 3.5 volts. When you have a cell that can do 50% of its discharge over 3.5 at 3.5 volts or higher, that's a really strong cell. So that's another thing. I look at these metrics, and but like to me, like the dip and recovery is a game breaker. So I'll notch it down like 5C. My car racing cells, like the factory says, it's they say, oh yeah, we did 45C cells. Well, I call them 40C. They can't do 45C. They have the dip and recovery, and at 40C they don't even hold like 50% of the discharge over 3.5. But they're amazing because they're high capacity cells. They have a really high milliamp hour per gram, and they have low DCIR. So the C rate is irrelevant especially for our car racing. It's like irrelevant. But so I go like that. That's another thing. Like I don't stay too stuck in that stuff. Like the FPV cell. If I were to test it, I would say it has a tendency of a small dip in recovery, but it's not one of these big dips in recovery. It just goes down a bit and then come. So it can do I can do 100C. But probably 95C would not have that little thing. But
how do manufacturers get to the sort of 120, 130, 150, 180C ratings?
Yeah, it's pretty simple. It's called printing it on a label and making it up.
Right. So there's not even like
very simple. Or in all fairness, if I set my cut, like my equipment, like it's very precise, so I can set the cutoffs at whatever I want. I can record to at 0.05 second, like I could 0.1 seconds less than that. It's very precise equipment. I have the same equipment as labs and factories. So in theory, I could discharge a cell at 200C for I don't know, a few seconds. It'll do it. It'll start to, you know what I mean? It's like,
so it's more like almost a short circuit test, and they're just looking to see how many amps it will push under almost.
I personally think they just make it up at this point.
Yeah.
they just go with the flow. They say, hey, look, this company has 100C. We'll make a cell that's a bit better. So you have to call it 120C. Then this guy has 120C. This other guy says, well, I have to be at 150C. That's why I didn't put C rates, because how do I call my FPV cell? Like, you've proven that it has less voltage drop than others. I've proven it myself. I have graphs on the side.
It delivers vastly more power.
Yeah. So what do I do?
Yeah.
Like, well, I think now that some companies claim 180C. So what? I come at 200. So then what? They relabel theirs at 220.
Like,
so
yeah, it doesn't work.
That's how it started. It's how it started. It's all marketing. I have a little video on my YouTube thing where I compared a bunch of packs on Amazon versus mine. I even say, it's even written in there that I lie about C rates, because guess what? SMC is not in business today if I don't try to follow some of the trends with C rate, because people will not buy packs if it doesn't have what they claim should be a good C rate.
Well, and actually, you know, for a lot of applications, you're giving particularly new pilots or new RC car hobbyists, you're giving them guidance to say, like, for FPV, make sure you buy batteries with at least a 100C rating.
Yeah,
because
exactly.
you don't want people buying packs that are designed for boats and cars.
Yeah, but here's the deal. Okay, if you go on, you can go like on Amazon, and there's some so-called 120C packs that are completely rubbish with like nickel, manganese, cobalt. They have crazy voltage sag, and they still call them 120C. So you can't rely. I always say, okay, perfect example. I'm not going to name names again. Okay,
you keep saying this. I kind of want you to name names now.
No, because I'm in this industry. I don't want to get in trouble. I'm not scared to get in trouble, but my whole thing is, every company could do what they want. It's their own perspective.
Of course.
But, for example, there's a 5,000 pack that's made by one factory. It's sold by two different companies, two different big companies. One company labels it as 25C. The other company labels it 100C.
Yeah, because they're just selling to different markets, aren't they? They have different.
Yeah, so C rates are they're kind of useless, but that's, like I said, yeah. I made it. I had a test. Like when I did, I was selling a 62 or 6,500 pack. I called it 25C. That was the real C rate. I have a video showing with my homemade equipment that it could do 25C. Everything was taped, everything.
Yeah.
I was selling. That's when my website, I started to sell online and got out of distribution. And I was selling, I don't know, 50, 60 packs a month, but everybody loved those packs. Well, everybody else was selling so-called 40, 50C packs. So I said, well, guess what? I'll label it as 40C. I started selling 3 times the amount per month.
Yeah.
So that shows how important what it says on the label is. And milliamp hour, there's a lot of companies cheating by milliamp hour. Most of the Amazon packs that are made with nickel, manganese, cobalt are rated as 5200s, and they can barely put 4700 milliamp hour. And nickel, manganese, cobalt has a tremendous amount of loss in capacity because it holds on near the end of the discharge curve a lot. So it's non-usable good capacity. So that's when you're packed. Yeah. So
you've got all that capacity, but it's when the voltage is basically when you're like, I have to stop. Or
yeah, exactly. So it's, but they call them 5200s. It's like it's a very messy market. But there's no standards. They're like I noticed something that's funny. Like if I'm the first company to put like my LCO on my packs. So when I sell a pack that's made with lithium cobalt, because that's more expensive material, it's better material.
Yeah, it is.
So I put 100% LCO. Well, guess what? The other day I was like on Amazon just looking what's going on. Some companies are now saying 100% LCO. Chinese companies selling on Amazon are starting to say it too. It's like
they're just following the.
Yeah, they say, oh, that's what we need to put now. We need to put that. So I've been a bit of a trendsetter. Like I've always done that. Like I said, back in the days, like that Competition Electronics Turbo Matcher, they were measuring. They had this IR reading that was called a relative IR number, and I said, relative? What does that? And I noticed I could easily manipulate it by how it's charging in the cells. I said, okay, so that's not good. So I asked them. I called the it's a small company. I talked to the engineer, the person there, and I said, could you figure out how to do the IR, like a real IR reading? And they did it in they had this thing called a Turbo 30, and they did it in that, and I validated it. Then I said, can you make it to work in my turbo matchers? So I was the inventor. Like, I didn't know how to. I was the first one to use that in my cell matching, and it made a difference. And when I first came out with that, and it shows you how people hate changes, and people think everything's a conspiracy, and you're out there to, and then people said, oh, you're doing this so you can sell your bad cells. And guess what? After like a couple of years, I was influential in that market. Everybody switched to that number, like to that way of measuring. But I wasn't happy with that other way of measuring because it was too easy to manipulate.
Yeah.
So
yeah. Well, that's why I stick with my testing to like basically energy density and power density.
Yeah.
And with those two numbers, you really do capture like a lot of the key performance.
Yeah, well, I looked at your videos, and then I said, well, when I came out with my FPV thing, I said, okay, I communicated with you. I said, I've got to find a way to test these, and so I came up with my own little ways, but it's all the same thing.
Yeah,
I'm basically for capacity, I'm doing a constant resistance discharge, and then for this, what would be equivalent to my C rate test, which is my voltage under load, I call it my burst power.
burst power.
I basically do like a constant. I'm confused. There's one that's constant power, and the other one's constant resistance, I think. Anyways, whatever. I'd have to look at my details. But that one's like a really high. Like, I just discharge for 3 seconds, or I think it's 3 or 5 seconds at like a really low resistance. It starts out at 205 amps or something like that, and it goes down. And of course, the crappier the cell, the more the amps go down, and the stronger the cell, and then the voltage stays up. Which
you can sort of measure the power that it's able to deliver.
Yeah, because to me that's like it's burst power, so it's like kind of punch. It's like how much, like if you accelerate full and you punch it, how fast will it? It'll give you more RPM, more power. So to me, that's the same as if C rates were real, it'd be the same as a C rate test.
Yeah,
but like I wanted to get away from C rates because they're not real. So,
no, and that's what matters for particularly like FPV racers. They're going around a gate or something, and they punch the throttle to accelerate onto the next gate.
Yeah.
It's how much power can you give them in that short time.
Yep.
So, well, I mean, it's an awesome deep dive. Before we finish up, I'd just love to get some of your thoughts on like what's coming up, looking ahead, and are there any projects that you're excited about that you're working on now that you want to give people a sneak peek on? Or
the next step is to try to go into advanced anode materials, which I hope will be possible. That's going to be the key to unlocking higher capacity and maintain like the voltage drop to be as high. You got to be careful. There's a trade-off. I've learned that with the EDF guys, because if you give them a pack that's the same size, same weight, and you're giving them more capacity, they're going to generate more heat because it like the watts, it has higher watts. So that's tricky.
There's more time for the pack.
So it's a tricky one when it comes to capacity. So I think there's a limit eventually to where we are, but I'll keep trying. And then I just trying to make improvements to. I'd like to release other cells, other like cell sizes and stuff like that, but it's very hard for me to know because that's another thing that a lot of people, when you're like I have to deal. I have my own cells that I buy, and they build into packs for me. So I have to deal with minimum order quantities.
Yeah, on the cell.
I can't say, hey, I want 100 of these packs, and they're not going to make 600 cells for me to have 100 6S packs. They won't even take my request, So I've got minimum order quantities to deal with. So I'd love to do other models, but I've got to make sure at the end of the day that I can move them. There's two reasons. First, I don't want to tie down money that would prevent me from stocking more popular models. And then the other thing, LiPo batteries do not get better as they stay sitting on a shelf. So when people buy packs and they buy like multiple packs and they save them for say, oh, I'll buy them and then I need them in a year or two. Well, that's not really a good investment in my opinion. Just buy what you need to use, and as it wears out, buy new ones. You know, and hope the place you buy from has fresh stuff. So a lot of times I get people, they're angry at me. I get emails. There's some people that are really not shy. So they say, the problem with your business, you never have what I need in stock. Da, 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 da. Well, there's a lot to it. First of all, the factory has to make it. I have to estimate how many I can sell. And then once again, I don't want to be selling you packs that have been sitting on my shelf for 3 years. You know, so I want my stock to rotate. So that's why we run out of stock. If I wouldn't care, I'd just buy way more of everything and
just leave it in the warehouse. But then, of course, that wouldn't be
exactly. So for new models, I want to do new models, and also I don't know what sells. So it's almost like I would need somebody that works in a shop or someplace that sells a lot of models that would give me the insight. I'm always looking for that, but I'd like to, because it's fun. I'd like to try to do the best of everything and everything if I can. It's always good to grow. Like that's why that big semi-solid state cell I showed. I'm thinking maybe coming out with these big UAV drone packs for agricultural and stuff like that, because I think not that my cells, I wouldn't be making custom cells for that. The factories that do these are doing a lot of R&D and making good cells, but I could come in probably with packs at a better price, because everything I sell is always at a good price. I'm known to sell like best performance at a fair price. Like my FPV packs, I think I could be probably selling them at a higher price. I had somebody
you're mentioning like the price of the FPV packs is the same as packs that are nowhere near as good in terms of
so I'm happy. And that's another thing. I'm trying to come out with a more that's one thing I'm working on, is to come out with a lower priced one, because I don't think everybody needs the absolutely very best pack. Like if you're starting, or I don't know, maybe when you practice or something, why risk damaging your best packs? You know what I mean? So and also probably for planes, because the 1400 size works in other application. I don't think they need FPV grade level racing packs.
No.
So I want to come out with like I'll put it under one of my other series, a lower priced cell. I want to release as much stuff as I can, as long as I know there's a market for it. So
I know a lot of people are excited and interested in potentially a 1S.
Yeah, well,
1S tiny root pack, but I know that those are, again, like you say, it's the order quantity.
Well, first of all, I don't have any data on like sales for that, so I know they sell a lot, but you got to remember, probably 20 of these. Like, well, if we just do my math,
people are buying like a pack of 4 or 5 of these for like $20 or something.
So like profit margins might still be okay. Dollar wise, it's not a big, but I still want to do it. The thing is, it requires the factory invest in different equipment. You don't make these cells on the same equipment as the bigger cells,
right?
So of course I've got to justify that I can buy enough for the factory to recoup their investment. So that's the tricky part. But I'd love to make one of those. Is that like I want to do it. So maybe as we get more and more of the regular bigger FPV packs selling, and maybe if I could take over more market share, which is the plan, maybe because I'm sure there's a lot of these things being sold for sure. But an MOQ. So let's say typically if I want stuff done at the new factory, it's like I've got to get 5,000 cells done of bigger cells. So like a 5,000 milliamp hour cell, I've got to get 5,000 cells done, which is still a decent. It's a decent amount of cells, because if you're selling that into 4S packs, like
It's like 1,200 cells. Yeah.
Yeah, that's
1,200 packs. Sorry.
Yeah, it's a decent amount of packs. So the cool thing is when you offer, for example, when my regular flight pack series, I'll offer 3S, 4S, 5, 4, 6S. So you do a batch of cells and you can build a bunch of different packs with that batch of cells. Also, if you offer the same size cell, same tooling. So let's say a cell is like 39 by 135 millimeters. That's the tooling. Well, I can make like cells that are 7.2 millimeters thickness and make some that are 8.5. Well, in the 5,000 cells, that's considered the same thing because they're just, for them, it's just a stamp. It's the stamping of a bunch of electrodes. They need to stamp.
How many layers they?
Yeah, because they want to use a whole batch of coating material, and then, so then it becomes in the assembly. So they program the machine to put like, I don't know, 40 layers for one cell and 55 for the other, and then one's thicker and one's thinner. So that's kind of how it works. And but basically, the MOQ for one of these little 1S things, it's going to be very, very high. I need to see sample cell wise, do they have the equipment to make sample cells, which they might. If I have to see if there's a way for them to make if I can make sample cells of one of these small cells and prove to myself and you that it's better than what's out there, then I'd be way more comfortable.
Yeah.
Say, okay, look, we come out, we've got the best one, we're price competitive. It's and once again, everybody's using, they seem to be using LiHV for those, which I understand why. It gives a little boost in capacity. And I believe this application doesn't pull a lot of amps.
No, the actual C rate of the discharge on like a tiny whoop pack is a lot lower than on a 5-inch FPV pack. That's for certain. But I think it's all about getting the most capacity for the weight because tiny whoops are not super efficient because the props are really small. So if you want flight time, you just need to carry a lot of energy because the motors and the prop is always going to be very inefficient. So you got to balance that.
Well, hopefully, hopefully I can convince the owner, but like I said, I have to see. I've never asked him, like he says, his investment, but what is it? Are we talking like $50,000 or $5,000? If it's $5,000, I'll invest it out of and he can just give me how many cells I need to purchase, and if I reach that that amount, he can just
get a rebate. Yeah,
exactly. But it's
well, I think this has been amazing. I don't want to take up too much more of your time. Any final thoughts before we wrap up?
Not final thoughts. All I can say is I hope people who try my packs, the SMC packs, our packs, enjoy them. And my goal is I'm committed to continue to try to make improvements and offering what the market needs. That's what I'm about. So
fantastic. Yeah. Where can people learn more about SMC racing, or where can they reach out if they want to engage with you?
Yeah, it's smc-racing.com is my website. It's outdated. That's another thing. I'm a low overhead. Yeah, I'm not a flashy. We're not a flashy company with the best website. You can tell it's like operated by me, very basic. I'd rather spend my money on R&D and offering better pricing than to be all flashy and all markety, all doing marketing. So I have a new website eventually I'm going to launch. It'll be a bit better. And then they can email at orders@smc-racing.com or info@smc-racing.com. They both come to me, and I'll be glad to try to answer questions. And we are, like I said, we are getting more packs out there in Europe and in the USA. It's going well. They're easy to get. So we'll just keep plugging along.
Fantastic. Well, I'll put all the links to all of that down in the video description, so people can find all the links to where to get hold of your packs there, and because they are really impressive performance for the price.
Great,
particularly ones that I've tested. Great. Well, thank you so much, Danny, for taking the time to talk to me today.
Thank you for doing this. It was fun.
I'm sure everyone will have really, really enjoyed it and learned a huge amount as well. I know I have. And all I can say is we wish you all the best of luck with bringing out these packs, and long may it continue.